For 20 years, the Galey Lord textile mill ran a highly efficient disposal program. Instead of paying to treat the industrial wastewater sludge from their South Carolina plant, they gave it away. They called it free fertilizer, and it was delivered directly to farmers across the PD region. Robert O'Neill was one of those farmers. He spread the material on his fields to feed his crops and sustain his third-generation farm. He had no idea the sludge contained toxic chemicals until his family's drinking water was compromised. State regulators began testing residential wells around the farmland in 2019. The results showed concentrations of synthetic PFAS chemicals hitting hundreds and in some cases thousands of times above safe limits. To understand the physical volume of this material, you have to look at where it came from. This image shows the massive wastewater lagoons used to collect the industrial sludge. Over 2 decades, enough of this waste was drained from these basins to cover 300 fields across 3 different counties. That's nearly 10,000 acres of contaminated land. A routine corporate cost-saving measure effectively distributed toxic waste across a major agricultural sector. But the data presented a glaring mathematical problem. The massive amount of poison sitting in those fields did not match the relatively low concentrations of PFAS that state regulators were recording at the wastewater plants. 200 miles north in Darlington, North Carolina, researchers were staring at the exact same discrepancy. A local wastewater plant's effluent was testing clean for PFAS, yet the river flowing immediately downstream was highly toxic. The sheer volume of pollutants in the water and the soil meant millions of gallons of synthetic chemicals were evading standard environmental testing equipment. The gold standard sensors said the water leaving the facilities was safe. That meant an invisible carrier had to be transporting the chemicals out of the industrial plants and into the environment. Dr. Lee Ferguson and his team at Duke University decided to bypass the standard sensors and completely change how they tested the water. This chart shows what happens when you use an advanced chemical process to convert all hidden PFAS precursors into a measurable form. The tiny sliver represents standard test results. The massive bar next to it represents what the Duke team actually found. The measured concentrations exploded upward by 80,000%, reaching 12 million parts per trillion. The source of that massive spike was a class of chemical called side-chain fluorinated polymers. Instead of dissolving in water, these form colloidal nanoparticles, thousands of tiny solid spheres. Standard mass spectrometry testing is designed to detect dissolved liquids. Because these polymers hold a solid physical form, they slipped right past the regulatory sensors undetected. The testing instruments were looking for a liquid, while the poison was leaving the plant as a solid. Because these nanoparticles are solid, they sink. During the wastewater treatment process, they settle directly into the heavy sludge at the bottom of the municipal tanks, which brings us back to the fields in South Carolina. Every load of that free fertilizer from the textile mill carried massive quantities of these invisible nanoparticles straight into the agricultural dirt. Dr. Ferguson described the effect as a slow-release pill. The solid particles sit dormant in the soil, slowly breaking down and shedding measurable, highly toxic PFAS chemicals into the groundwater over the course of decades. The contamination is so severe that the EPA is currently evaluating whether to designate those 10,000 acres of active working farmland as a federal Superfund site. A Superfund designation forces an immediate economic freeze. Banks stop issuing mortgages, agricultural operations are suspended, and the community endures a 10 to 30-year federal takeover of the local economy while the site is remediated. State regulators repeatedly approved the sludge application, failing to halt the process even after the pollution became known. Now, taxpayers are looking at an estimated cleanup bill between $50 and $200 million. The nanoparticle discovery dictates how we have to handle industrial waste moving forward. Because the chemicals act as an invisible, slow-release pill, waiting to filter the water after it hits the soil or the river is already too late. Relying on careful sludge management or hoping for federal Superfund remediation programs are secondary defenses. They are expensive, reactive methods of damage control for chemicals that have already escaped. To actually prevent the pollution, you need a primary layer of source control. Biological technologies, like Biocleaner, can partially degrade and capture these complex precursors directly inside the industrial plant, neutralizing the threat before it ever enters the municipal sludge. You cannot effectively clean an invisible, slow-release poison out of a 10,000-acre footprint. True environmental protection means stopping the chemicals at their origin. Municipalities that proactively clean their industrial waste at the source will protect their farmland and their economies. Towns that wait will simply become the nation's next Superfund sites.